Right. So while we were discussing group 15, we discussed about the general properties of all the elements in group 15. Now let's see individually one by one, starting with nitrogen. The preparation of
Yes,
nitrogen commercially, it is prepared by liquefaction and distillation of air itself. That is the best source available. Liquid
yes,
nitrogen usually distills at 77.2 kelvins, while oxygen distills at 90 kelvins. Got it?
yes,
There is a difference in the boiling point, so that's why we use this technique. The
yes.
lab preparation, on the other hand, is when you take ammonium chloride, react with NaNO2. Okay,
Mm-hmm.
so that's a better way to prepare N2. Here you can notice ammonium chloride in the presence of NaNO2. Okay, NO2 minus here will act like an oxidizing agent. It will oxidize the nitrogen which is at -3 state to 0. And here this
Mm-hmm.
is being at +3 state, it will convert into 0. So that's how there is a calm proportionation. So this part is getting reduced, this part of nitrogen is getting oxidized. Got it?
Yes, yes.
So that's how NO2 minus will be able to convert that into N2. Got it? In fact, you can think it more like an more like a disonium salt reaction. If you recall, when you have RNH2 plus NO2 plus, do you remember NO plus? Okay, RNH2 plus NO plus. This was the preparation for disonium salt, right? Rn2 plus
R and two,
NH2,
yeah. Hmm.
and this is unstable, so you will get this as R plus N2, isn't it?
Yes,
You could imagine the same way here also, as if N2 is coming out. Instead of R, it is only hydrogen. So it is hydrogen like this NH2, and this NH2 is converting into that NO group. Okay.
so much, yeah. Hmm.
While doing this, there might be still a small amount of NO or HNO3 present. Got it?
Right.
Along with N2, we might have that small amount of NO or HNO3 present here. So to remove
Yes,
these impurities, because this might come out as vapors, to remove these impurities, what we can do, we can add some K2Cr2O7 with H plus. Okay, keep it in the same
mm-hmm.
test tube, so that whatever the NO plus content is, that will convert into HNO3, and the N2 gas
Right.
without any reaction will come out. Okay,
Hmm.
so now the vapors which they come eventually would only be N2, rest of them will get oxidized. Clear?
Okay, yes,
Then nitrogen is the best source to obtain from ammonium salts. For example, if you take this ammonium dichromate salt, you heat it, nitrogen will convert into N2, chromium will convert into Cr2O3 and H2O. Got it?
yes,
Now here chromium, which is at +6 oxidation state, will get reduced to +3, while nitrogen will get oxidized to 0. Got it?
hmm.
On this, there is a concept we can understand that whenever we take ammonium salts, there are two types of ammonium salts. One is oxidizing ammonium salts. Okay. The
Mm-hmm.
other one is non-oxidizing ammonium salts. That
Okay,
means oxidizing ammonium salts are connected with anions which are oxidizing agents. These are all oxidizing agents.
ठीक है.
Okay. Dichromate, NO2 minus, NO3 minus, MnO4 minus, MnO4 2 minus, ClO3 minus. ये सारे oxidizing agents, which means
Yes,
they will oxidize the ammonium part into converting that into nitrogen, N2 gas.
hmm.
While you have non-oxidizing anions also, like sulfates, phosphates, chlorates. Okay. Uh, uh, Sorry, this is chloride. Yeah, this is chlorate, chloride, bromide, iodide, and oxalate. Now,
Hmm. Hmm.
these
Hmm.
are already, I mean, they are non-oxidizing because of different reasons. For example, sulfate, although it has +6 oxidation state, it is highly resonance stabilized. So it does
Yes,
not have its effective oxidizing nature. See, the
yes,
oxidizing nature of sulfur would be with H2SO4, not with a sulfate ion. So there is a difference in these two.
yes,
Same goes with phosphate, same goes with chlorate, perchlorate. Then Cl minus, Br minus, I minus, they are coming from a very strong acid, and they are already in a highest reduced form. They cannot be further reduced. That's why these can be used with an ammonium salt, where ammonium will convert into ammonium ion will convert into ammonia and not into gas. Okay.
Right.
Next. That's why if you compare these two, you can see dichromate with respect to dichromate, you get nitrogen. With respect to
Yes.
nitrite, see NO2 minus also you get N2, which was also a lab preparation, right?
Yes.
At the same time, if you notice, by chance, if there is a nitrate, NO3, correct? In nitrate, what happens? There is an extra oxygen here, beta. That will
Yes.
again combine with N2 gas and finally convert into N2O. So instead
Yes.
of getting only N2, you will get N2O instead. So ये थोड़ा सा
Yes.
difference समझना है इसको. When you have ammonium nitrate and ammonium nitrite, what is the difference there? Okay.
Yes.
And later, heating azides is one of the better way to extract the pure form of nitrogen, because here the other impurities are rarely observed, right? So because barium and azide are present, so the entire barium part will get easily reduced into the solid state here, and nitrogen will come out as N2 gas here. Okay. So whether you take
Yes.
sodium azide or whether you take barium azide, it will easily convert into pure form of nitrogen. Got it?
Yes.
Same logic, if you take urea and react with HNO2, this is the same disonium salt reaction. You can see NH2 react with this NaNO2 HCl, which will produce NO plus. And as the lone pair attacks here, eventually it will convert into N2 plus on both sides. And as you hydrolyze it, N2 gas will come out, and carbon C double bond O will connect with two OH groups, which will eventually convert into carbon dioxide. Okay.
Yes.
Clear? So this is how you will get the product formation by heating azides and heating urea. I mean reacting urea. Okay. So
Yes.
these are few ways to extract nitrogen or prepare nitrogen gas. See, you can make ammonia to oxidize with cuprous oxide, where copper will get reduced on heating, and the ammonia part will convert into N2 gas. Okay, this is again an industrial way of obtaining nitrogen gas.
Yes.
See, what are the important properties of nitrogen? Nitrogen is very less reactive gas due to its very high bond dissociation energy, N triple bond N. So you have to break all three bonds to make any reaction. So unless the product is highly stable or it has very high bonds compared to that of triple bond, it does not break that easily. Okay.
Okay.
That's why N2 carbon monoxide cyanide have same bond order, right? While carbon monoxide and cyanide are relatively more reactive due to their polarity, correct, in their anti-bonding orbitals, but nitrogen does not have that problem. Okay, nitrogen
Okay.
will be leastly reactive here. But yes, with metals it could react like this. You can see with lithium and magnesium, it can form nitrides, lithium nitride and magnesium nitride. Got it? So you can see metals react with nitrogen to form metal nitrides. But these metals have to have very strong ionic bond with nitrogen, which means they need to be smaller in size, okay, with high positive charge on them, like this
Yes.
nitride and 3 minus. Got it? So 3 more, sorry,
Yes.
plus here and 3 moles of this and then 3 minus, like this. Same goes with
Mm-hmm.
magnesium. So in fact, if you take sodium and try to react with nitrogen to get a nitride like this, that's not possible directly. Sodium
Okay.
nitride would exist, but not directly as a reaction this way. Okay.
Okay.
And next is nitrogen reacting with hydrogen will give you ammonia. Okay. Born-Haber process.
Yes.
Here again, nitrogen hydrogen bond is a very strong bond. So that's why it facilitates the breaking of nitrogen nitrogen bond. And N2, when you react with boron, makes it boron nitride. Aluminum will make aluminum nitride. While aluminum in the presence of carbon can also be reduced into aluminum, and then aluminum can react with nitrogen to again form aluminum nitride plus carbon monoxide. Okay. So these are typical reactions noticed for nitrogen gas. Next, nitrogen does not react with oxygen, or the air does not have any nitrogen oxygen reaction at a normal condition unless you push it around 2000 kelvins or an electrical arc. Then they will have a conversion of NO gas, which you will see mostly in stratosphere, where nitrogen oxygen can interact with each other to form NO gas. Got it?
Yes.
What are the other compounds of nitrogen? First one being ammonia, which is most important one in nitrogen cases. Preparation wise, you can directly take ammonium salts, add it with basic medium. So
Mm-hmm.
ammonium will convert into an ammonia. Same goes with ammonium sulfate reacting with calcium to form ammonia and calcium sulfate.
Yes.
The reduction is also very well used reaction. That is, if I take sodium nitrite or sodium nitrate with zinc and hydroxide, zinc will provide the electrons. So it's an electron in the presence of basic medium, it will dissolve very easily. It will release a lot of electrons. Those electrons will try to combine with nitrogen, and aqueous solution will facilitate H plus insertion. So H plus will get attached with nitrogen and convert that into ammonia. Okay. So it doesn't matter whether it is in a nitrogen is with plus 5 oxidation, plus 3 oxidation state or plus 5 oxidation state. This would happen.
Okay.
Clear? Right. Okay. Just a second. Hydrolysis of nitride, if you notice, Mg3N2, Mg3N2 with H2O will form magnesium hydroxide and ammonia. Okay. Same way, aluminum nitride on hydrolysis will become aluminum hydroxide and ammonia. Magnesium nitride on HCl will also become MgCl2 and ammonia. So you can see these are all the nitrides. Nitrides usually on hydrolysis, because they have N3 minus. So they can take H plus very easily from water and convert themselves into ammonia. Okay. Next, heating ammonium salts with non-oxidizing anions. Just now we have noticed that. That is, in case
Yes.
if you have ammonium chloride on heating, we can get ammonia plus HCl. And ammonium sulfate can also become ammonia plus SO3 here.
Hmm.
Phosphate can also become ammonia plus P4O10. Got it?
Yes.
Right. Next, check out hydrolysis of urea. Okay, urea also we learned. Earlier, we didn't use this reaction with water. Instead, we used it NaNO2. With NaNO2, we
Hmm.
converted that into N2 gas. But what if we directly hydrolyze that? On hydrolyzing, this nitrogen part will convert into ammonia, and the carbon part which is left, that will convert into carbon dioxide. Okay, right.
Yes.
And this we have just learned it, that how NaNO2 can be converted into ammonia part. And see, this one is a very important reaction from JEE advanced point of view. So that's why I picked it. See,
Okay.
whenever you do hydrolysis of calcium cyanamide, now how do we get
Yes.
that? First, you take calcium oxide, react with coke. On heating it
Mm-hmm.
strongly, the carbon will convert into carbon monoxide gas, and few more moles of carbon will convert into carbide, calcium carbide.
Yes.
Calcium carbide, when you connect with nitrogen, this carbon will break down into 2 moles of carbon calcium cyanamide. So you will have C
Okay.
double bond N and C double bond N with a minus and minus charge with calcium 2 plus. This is
ठीक है.
called calcium cyanamide. And calcium cyanamide with some amount of carbon, the released carbon, one more carbon, there are two carbons, right? The other carbon will be in a reduced
Hmm.
form. And this mixture is called as nitrolim mixture. This is called nitrolim mixture. And
Yes.
this would have, resonating structure in two different ways. I can put this lone pair here, push this minus charge here. So that way we'll get N triple bond C single bond N with two minus, right? So
Mm-hmm.
that's the resonating structure which I have written to showcase the mechanism, how it happens. So if you added water, this N2 minus will take two hydrogens to convert that into ammonia, hydroxyl. Sorry, this is cyano, you know, with an amine, correct? This is like cyanoamine. And that when you hydrolyze it, the CN will get hydrolyzed to form COOH. Got it? And this part of nitrogen will convert into ammonia. Suppose if at all I do the same thing in a slow process, that means a controlled hydration is being done, then you can convert that into urea. Okay. And this
Yes,
becomes an
sir.
important method for preparation of urea industrially. Got it?
Yes, sir.
So calcium oxide is a cheap source. We can react with coke, which is also easier to make blend of these two to convert into calcium cyanamide. And once calcium cyanamide you have it, controlled hydrolysis will convert that into urea form. Got it?
Yes, sir.
Right. In fact, if at all I react this with calcium, I mean, if you heat the hydrolyze this further, right? This is a carboxylic
Hmm.
acid, this is amine. So amino carboxylic acid, if you hydrolyze further, this will convert into carbon dioxide and this will convert into ammonia. And eventually this
Hmm.
can be again reacted with calcium hydroxide to convert that into calcium carbonate. So nothing goes for waste. Got it? So this is an important concept of preparing ammonia at the same time preparing calcium carbonate. Clear, beta?
Hmm. Hmm. Hmm.
Okay.
Yes, sir.
Next, what is Haber's process or Born-Haber's process? If you take nitrogen, react with hydrogen, chances are it could form ammonia. But because both of them are gases, right, they require high activation energy for converting them into ammonia. Overall
Right.
reaction is still exothermic. The pressure
Yes,
at which
sir.
it has to be maintained is around 100, 200 atm, and temperature is around 700 kelvins.
Yes,
Okay.
sir.
Earlier, the old catalyst that was used was iron. Iron would absorb the hydrogen gas, and then nitrogen gas will make a better orientation towards hydrogen gas present on the metal surface to convert into ammonia. So this would enhance the rate of reaction. To increase the adsorption of hydrogen, we can use molybdenum that will act like a promoter. Okay.
Yes, sir.
While this was an old catalyst, it has been replaced by a better catalyst, which is K2O plus Al2O3 mixture with Fe2O3. Okay, the role is the
Yes, sir.
same. They will also absorb hydrogen gas and increase the attention of nitrogen towards hydrogen. Okay. See, ammonia
Yes,
generally
sir.
is colorless, pungent smelling gas. It will hold hydrogen bonding in liquid and solid states. It is highly soluble in water due to its intermolecular hydrogen bonding with water. How does it react with O2? It can burn with oxygen to give a yellow color flame. In fact, any ammonia or amine forms
Hmm.
in atmosphere, they will burn and they will start giving a yellowish color, a yellowish tinge, which is of nitrogen gas.
Okay.
Got it?
Hmm. Yeah, sir.
The next important reaction, what you need to, practice, I would suggest, is ammonia with chlorine. Okay.
So
See,
एक सेंसर वॉशरूम यूज करना है सर वन
yeah, sure. I was telling you that ammonia with chlorine is a very important reaction. This is done in two ways. One, taking ammonia in excess, or
ओके
chlorine in excess. If I
यस
take
सर
ammonia in excess, let's say 8 moles
यस
of
सर
ammonia reacts with 3 moles of chlorine, I would expect nitrogen of 1 mole and 6 moles of ammonium chloride to form. Got it?
ओके
The reaction typically goes with this mechanism that ammonia, when you react with chlorine, chlorine acts like an oxidizing agent. So
ओके
it will take 2 moles of that, okay, and convert. I mean, when you take this sort of first 2 moles of this ammonia, reacts with 3 moles of chlorine, converts that into N2 plus 6 moles of HCl beta.
ओके
Okay, and this 6 moles of ammonia and 6 moles of HCl, because they can make an acid base reaction also.
अच्छा, and then they will form
So ये
6 moles
दोनों
of
acid
NH4
base
CL.
बनेंगे to convert into ammonium chloride. That's how
Got
overall
it.
reaction will have 8 moles is to 3 moles, giving 1 mole is to 6 moles of ammonium chloride.
Yes, sir.
Right? This is when the ammonium is in excess. Okay.
Yes.
Now, what if, you know, uh, chlorine is in excess? Now, notice if I take 2 moles of ammonia and 6 moles of chlorine, then nitrogen will convert that into NCl3 and 6 moles of HCl will be present. Okay. And because
Yes,
ammonia
sir.
is not in a larger quantity, this HCl cannot be further utilized. See the
Mm-hmm.
mechanism here. 2 moles is to 3 moles, which we have done it earlier also. So you will get N2 plus 6 HCl. यहाँ तक तो ठीक है. But this N2 which is forming can further react with chlorine, which was, excess present. And on reacting with that, it can convert into 2 moles of NCl3. And
Right.
overall, now if you notice the reaction, it is 2 is to 6 moles to convert to get the product as 2 moles of NCl3 and 6 moles of HCl.
समझ
Are they
गया.
clear, beta?
Yes, sir.
Right? So I would suggest you to please watch this once and try to redo that. Okay, do it once, please. Next is the reaction with bleaching powder. Ammonia, when you react with a bleaching powder like CaOCl2, of course, COOCl is a good oxidizing agent. It will convert ammonia part into N2 and this will become
Yes, sir.
CaCl2. Chlorine is getting basically reduced and ammonia is getting oxidized. Hmm.
Yes, sir.
And if you react with ammonium hydroxide, this will act like a buffer, isn't it? NH4OH and NH4Cl is a buffer, basic buffer. Hmm.
Oh, yeah.
And this basic buffer will have very small amount of concentration of OH minus. Okay, because of the common ion effect, its ionization will be very, very less, right?
Right.
And because of which, what happens? Clear? Now you would notice that uh, aluminium, chromium, iron that can be precipitated, and this is used in a group 3 in salt analysis. Correct?
Yes, sir.
In the cationic tests, we can use that for precipitation
Correct,
purposes.
correct.
HgCl2, Hg2Cl2 is also being used to figure out their presence, uh, in salt analysis using ammonia. That is, when you react with ammonia, HgCl2, it will become HgNH2Cl, which is a white color PPT. While if you took Hg2Cl2, Hg separate ho jata hai. This I told you before. Although this
Yes,
is
sir.
white, the mercury will dominate its color and overall it will become a black color. Okay.
Yes, sir.
Now, moist ammonia should not be dried using these compounds, okay, because they are acidic in nature. Correct? You might ask, sir,
Right.
calcium chloride तो acidic नहीं है. Problem क्या है? Calcium chloride can start making, complexes with ammonia here like this.
Right.
So even this has to be avoided. Understood?
Hmm.
So therefore, calcium, ammonium should not be dried. That means you cannot see, our objective is to remove ammonia, separate करना है water से, correct? So
Yes, sir.
H2SO4 we are expecting कि ये water absorb करेगा. But at the same time, it will react with ammonia also, no, beta, because of acid-base reaction. And the same
Yes,
logic goes
sir.
with P4O10. And here the logic is different. You are trying to extract ammonia or separate out ammonia with water, but that itself will make a complex with calcium. Instead, what
Yes,
you do,
sir.
you use calcium oxide. Now, first of all, calcium oxide is basic compound. Base will not
Yes,
interact
sir.
with base, correct? But it
Yes,
will
sir.
absorb moisture easily, convert into calcium hydroxide. So it is able to separate moisture out and leaving behind ammonia. Okay. Again, this is a
Yes,
JE
sir.
question. Which of the following is used to separate moist ammonia or dry moist ammonia? Okay. What
Yes,
is to be
sir.
used, beta? Calcium oxide to be used.
Calcium.
Got it?
Yes, sir.
Next, check out hydrazine. Hydrazine is prepared by rashing process in which ammonia is oxidized with dilute solution of NaOCl or calcium chloride. That is, if I take ammonia, react with NaOCl or CaOCl, it will convert into N2H4. But you might wonder,
Yes,
sir,
sir.
इससे पहले हमने N2 बोला था, अभी ये कैसे हो रहा है? Correct?
Yes, sir.
So you need to take a very dilute solution, beta. We cannot take a powdered bleach powder नहीं लेना चाहिए, a dilute solution लेना चाहिए, and it has to be very controlled oxidation. So then
ठीक है, sir.
ammonia will be controlled to form N2H4. Okay. See, how
Yes.
does the reaction proceed? The first step is OCl minus will interact with ammonia, convert that into NH2Cl. Okay, it will
Yes,
convert
sir.
that into NH2Cl. And NH2Cl will again interact with ammonia, correct? So thereby HCl will come out of this position and N2H4 will form. This is the hydrogen vapors which you will get. Okay.
Yes, sir.
And depend, like I said, it depends upon the concentration of NaOCl. अगर तो थोड़ा भी ज़्यादा है, that means NH2Cl ज़्यादा बन जाएगा. If
Yeah.
this becomes excess, that will again react with hydrazine to convert that into N2 gas, and which is what we earlier explained, that N2 gas
Yes.
बन जाएगा if I take the powdered form of it. Okay.
Yes, sir.
Now the side reaction is catalyzed in the presence of heavy metal ions. So to prevent this reaction, the reaction is carried out in a distilled water using little amount of glue or gelatin, which mask the metal ions if at all they are present.
Glue.
Okay. Yeah. So basically, gelatin or glue can be used so that they can be like a layer on the surface of the metal, so that it will not catalyze the uh, hydrazine to convert
Second
this
reaction.
NH2Cl to make into ammonia form. Okay.
ठीक है, okay.
Now, this statement has been asked earlier, that how the reaction is carried out in distilled water and what is the role of gelatin. Okay.
Okay.
So remember this line. Yeah. What are the properties? See, hydrazine is a colorless liquid which smells like ammonia only. It reacts with air readily, produces a high amount of energy. So N2H4 reacts with O2, convert into N2. N2 is a very stable molecule. That's why huge amount of energy is released, highly exothermic. And that's the reason why
Yes,
we
sir.
use it in rocket propellers, right? Okay. So
Oh,
hydrazine is the fuel for rockets. Got it? So the
okay.
thrust which it can give is, high, very high impact it can produce on the ground. Okay.
Okay.
So in aqueous medium, it acts like a strong reducing agent. So if I take it in aqueous medium and react with I2 here, you can convert that into a strong reducing agent. That means it can reduce the compounds like I2 to convert into HI, O2 into H2O, MnO4 minus into Mn plus 2. Got it?
Yes,
And
sir.
respectively, it will convert into N2 gas. It will
Okay.
also reduce the less electropositive elements, which is copper 2 plus, silver 2 plus, and gold 3 plus. They all will also convert into metals, releasing N2 gas. Okay, so these are all those
Yes, sir.
reactions you can notice. And when you react with zinc and HCl, this is where it will act like a oxidizing agent, wherein zinc will get oxidized to ZnCl2 and N2H4 will reduce to NH3. Got it?
Okay.
And you notice that the reduction potential of N2H4 to ammonia is also positive. N2H4 to N2, which is oxidizing potential, is also positive. It all depends upon
Hmm.
with what you are react. Okay.
Yes, sir.
Got it? Hydrogen is clear, beta.
Yes,
Next,
sir.
notice what are the oxides of nitrogen which you will observe. So, first oxides, if you notice here, oxo acids, I'm sorry, oxo acids, if you notice, hyponitrous acid, hyponitrous acid, only structure is important here. N double bond N with OH and OH, if they are on the anti position, or if they are on the syn position. These are the two forms of hyponitrous acid that exist. Hmm. Next one is nitrous acid. Nitrous acid is HNO2. Structure wise, this is how it looks like, with sp2 hybridized nitrogen and oxidation state being +3.
Yes,
Nitric
sir.
acid HNO3 is +5 oxidation state, sp2 hybridized. right, with one OH group here. So this is the structure which you will have. Then you'll have per-nitric acid as well, which means instead of directly having OH group, you'll have OOH group. So there is a peroxy linkage in between. Now, this one, first one, hyponitrous acid is stable at relatively low temperature. Okay. And as the
Yes,
temperature is increased, it will convert into N2O plus H2O. Okay. Now, this is
mm-hmm.
very interesting to understand that on heating, it will give N2O. Correct. That means the back reaction is not true. You cannot make N2O to add to water and convert back into an acid. Got it?
Yes,
Why? N2 is a neutral oxide, but a neutral oxide does not react with water or acid or a base to create something uh, which is acid or base again. Okay. So this
yes,
is not an anhydride. It is not an anhydride. Acha, what do you mean by anhydride? Anhydrates are those which on hydrolysis will give you their respective acids or bases. Okay. For instance,
mm-hmm.
if I take carbon dioxide added to water, what do we get? Carbonic acid. Sulfur dioxide added to water. So what do we get? Sulfurous acid.
Sulfonic acid.
Okay. Now, if you
Yes,
notice, if I call what is the anhydrate of carbonic acid, answer is CO2. What is the anhydrous of sulfurous acid? Answer is SO2. Correct. But now I can't say the same for this one. Can I say that the anhydrate of H2SO4 is N2O? No. So it
no,
is not an anhydrate of N2O. Okay.
yes,
On overall, we have only four neutral oxides that includes NO, N2O, CO, and H2O. Okay.
yes,
Next, see N2O5 when you hydrolyze. I mean, this is what I told you already. So N2O5 is an anhydride of HNO3. Okay.
mm-hmm.
Next, if I add NO2 to water, right? What happens? One
Yes,
will become HNO2, the other mole will become HNO3. So basically,
oh,
this is also an anhydride, but dono acids ka anhydride. That's why this type of oxides are called mixed
mixed
anhydrides.
right?
So this is a mixed anhydride of HNO2 and HNO3. Okay.
Yes,
Similarly, ClO, ClO2, ClO3 ये तीनों भी mixed anhydrides है. आगे जाके यूज होगा ये wording. Okay. So this
okay,
is mixed anhydride. Next. Next, check out nitrous acid, HNO2. Okay. So HNO2 is a stable, it is stable only in dilute solutions. Beta. It can be prepared by acidification of barium nitrite with cold dilute H2SO4. Okay. That is,
yes,
if I take barium nitrite, react with cold dilute H2SO4, barium sulfate will precipitate and the remaining will be HNO2.
yes,
N2O3 when you react with H2O will give you HNO3, HNO2. So यहाँ पर ये कह
yes,
सकते हैं definitely that N2O3 in fact is an pure anhydride of HNO2 because you are not getting anything else. Okay,
yes,
clear?
yes,
So N2O3 is an anhydride of HNO2. Next, HNO2 is a weak acid. When you react with
mm-hmm.
NaOH, will make an acid-base reaction. But just over room temperature, right? HNO2, just over room temperature, it will easily undergo disproportionation. So it will convert
Yes,
into HNO3 plus NO. Just put that. So HNO2 will convert into HNO3 plus NO. And it is a disproportionation reaction. Clear?
yes,
1 second. HNO2 acts like both oxidizing agent and reducing agent. Okay.
yes,
So when it comes to oxidizing agent, basically it will first get hydrated, gets H2O out, convert itself into NO plus, and NO plus will
right,
eat away electron as an oxidizing agent and convert into NO gas. This is when it acts like an oxidizing agent. Okay. When it is reducing agent, it will convert into HNO3. Got it? See, what are the oxidizing agent reactions? It will oxidize the compounds, which are very, very mild or very strong reducing agents,
Yes,
like
sir.
S2 minus. S2 minus is a strong reducing agent, either in the form of H2S or in the form of any salt S2 minus. It will convert into colloidal form of sulfur, and this HNO2 will reduce into NO. I
Hmm.
minus will get oxidized into I2, reduce
Hmm.
HNO2 to NO. Fe plus 2 to Fe plus 3, cobalt plus 2 to cobalt plus 3, SO2 to H2SO4, Sn plus
Right.
2 to Sn plus 4. Okay,
Hmm.
these are all the oxidizing agent reactions.
But what happens at H
Where? Which one?
in all of them except SO2?
SO2 is also converting into SO3, no beta. SO3 in aqueous solution is H2SO4.
हाँ वही कह रहा हूँ जैसे अब for example in I'm in Fe2 plus, right?
हाँ,
We got Fe3 plus NO.
correct.
तो वो H का क्या हुआ? It's just floating around in solution as
That is
HIN.
forming, see, this HNO2, when you have it, basically it is like water and NO plus, isn't it? And
Um,
you facilitate this in acidic medium
yeah,
usually, correct?
correct,
And this
yeah.
water will make complex with Fe plus 3. Got it? Same with cobalt
Oh,
plus 3. Got it?
समझ गया. Okay, okay,
Hmm.
okay, okay, okay.
Next, as a reducing agent, it will
So
convert
that could
itself
form
into,
the green ring compound.
pardon,
Fe plus 2 could form the green ring compound.
green ring,
Brown ring, sorry. I'm
brown
being
ring.
crazy. Yeah,
Yes,
because you
yes,
have NO
that's
also, you
correct,
have that
correct, correct,
also.
correct. Okay, okay, I understood. See, if at all I have a freshly prepared FeSO4, and
Yeah.
then you add dilute H2SO4, correct, with on from the sides of the walls, and then, correct, you have any nitrous salts, correct, that is NO2 minus salts in it.
Wait, so
Yeah.
HNO3 won't work there?
No, I'm telling you first brown ring test with NO2 minus.
Acha, okay, yeah, okay.
So in this case, what happens is we will have a complex like this forming H2O,
I know.
5NO with SO4. Okay. And
Yeah,
this will be appearing like brown ring form. Okay.
yes,
While
so.
if you have FeSO4 and I want to check out NO3 minus, right? In that
Huh.
case, first I need to add some concentrated H2SO4, not dilute, convert some
Oh,
part of that into Fe plus 3. Okay.
okay.
And then this Fe plus 3 is being interacted with uh, dilute, sorry, NO, my mistake, NO2 minus, yeah, this one, NO2 minus here, correct? And this will make back into Fe plus 2 and convert this into NO3 minus, sorry, NO3 minus. That will convert back into,
Ew.
sorry, one second, galat lik diya. Okay. So you have NO3 minus here, isn't it? Clear? So
Yes,
that
sir.
NO3 minus basically will interact with the H plus which is present, converts into this HNO3,
Yes,
and this HNO3 is an oxidizing agent. Beta. Clear?
yes, sir.
So it will also convert some part of Fe plus 2 into Fe plus 3 and converts itself into, you know, NO gas. And this
Yes,
remaining FeSO4 is the one which will react with NO plus H2SO4, correct? And that will again form
yes,
into a
sir.
brown ring. Got it?
Yes, sir.
So this way it would happen in NO3 minus. Okay. So the
Yes,
idea here
sir.
is, this is a lab setup to understand NO2 minus and NO3 minus presence. Okay. Yes, this is
Yes,
also a
sir.
part of a similar reaction. Correct. But this is very momentarily, right? The brown ring is not stable. You just shake it again, it will get back into NO gas.
Okay.
Correct?
Yes,
Hmm.
sir.
And whatever the SO2 minus SO2 is present, that will convert into H2SO4 again. Okay. Hmm.
Yes, sir.
Let's see about the reducing agent. HNO2, when you interact with KMNO4, it will convert into Mn plus 2. K2Cr2O7, it converts into chromium plus 3. Peroxide to water, Cl2 to Cl minus. These are very very common oxidizing agents बेटा. Most of the compound के साथ ये use करते हैं हम लोग. They will be
Right.
good oxidizing agents. They'll convert into these respective compounds, and HNO2 in
Mm-hmm.
this case will convert into HNO3. Okay.
Right.
Now let's talk about nitric acid. Okay. Nitric acid's preparation is done by two methods. One is Birkeland-Eyde process, wherein we
Okay.
take air and take it in a glass container, or a very strong container, what do you say, something like a cathode ray tube, and then conduct
Okay.
electrical arc so that it will be converted into nitrous oxide. Okay, nitric oxide. This nitric oxide, when you react with uh, oxygen present in air, it will slowly convert itself into NO2. And once you
Okay.
get NO2, you will see NO2 is a brown color vapors. Okay, brown
Yes,
color
sir.
vapors. And you take those vapors and slowly pass it through H2O. It will convert into HNO3 and HNO2. And see, HNO2, I told you earlier, at around room temperature, it will start slowly disproportionating into HNO3 and NO gas.
I know. Yes, sir.
And NO gas, again, you recycle back into the second step here. Okay.
Ooh,
So that's
smart.
how, again, it will keep converting into HNO3.
Okay.
Okay. So eventually you'll have large quantity or high concentration of HNO3 into the solution. Okay.
Okay.
This is Birkeland-Eyde process. Clear? Yeah. The net reaction is like this. N2 plus O2 plus H2O is becoming HNO3. But it's not exactly the way it seems like. So there is a strong interaction of N and O reaction there. Clear?
I see.
See, what are the steps that are taking place here? Okay. Nitrogen is oxidized with NO, O2, and NO, when you combine with O2, it produces NO2. Okay.
Yes,
And
sir.
NO2, when you dissolve in water, it produces HNO3 and NO.
Yes,
And
sir.
see, HNO2 formed will also disproportionate to HNO3. These are all the main steps that are happening. Clear?
Mm-hmm.
Next, if you notice Oswald's process, the second type of process is Oswald's process. Here we take ammonia beta. Instead of nitrogen gas, we take ammonia. Ammonia, we let it oxidize in the presence of O2. But for that, we take platinum gauge, got it? Or rhodium,
Yes, sir.
platinum or rhodium at around 500 kelvins and 9 bar pressure, got it? Now, when you take
Yes,
this
sir.
high pressure and temperature, most of this nitrogen will convert into NO gas.
Yes,
And
sir.
thereafter, the reactions are same. NO gas will be further interact with excess oxygen so that it converts into NO2. And NO2 on hydrolysis will convert into HNO2 and HNO3, and HNO2 will get again converted into HNO3. Okay.
Yes.
So only the first step is different in both the cases. Okay. Birkeland-Eyde process as well as Oswald's process. There are only two, the first step being different. The way to generate NO is different. That's it. Hmm?
Yes.
Now, when it comes to aqueous HNO3, on distillation, it produces an azeotropic mixture, which is around 65% HNO3 by mass. And see,
Yes, sir.
HNO3 is further concentrated by treating it with concentrated H2SO4, which act like a dehydrating agent. So this way you can remove all the water and you get 98% HNO3. Okay. So which means at this composition, right, when you have 68% by mass, of water
Yes.
and HNO3. You will not be able to separate them. That's why we need to add a
Yes.
concentrated H2SO4 so that it can consume up all the water and leave behind HNO3. Okay. See, HNO3 is a colorless liquid, and as it is appearing to be long standing, it will start giving a brown color gas due to its decomposition in the presence of light. Okay. The brown color
Yes.
gas is NO2. Okay. And it decomposes to give H2O and O2.
Oh,
Okay.
smart, smart. Okay.
Clear. Sorry, this is not yellow. I put it wrong. Okay. Yellowish brown color gas. Now, HNO3 acts as very strong oxidizing agent, but its oxidizing nature keeps decreasing based on concentration decreasing. If it is at a dilute condition around 6% by mass, its oxidizing power is less. 20% moderate, 60% high oxidizing power. Okay. So increasing
98%.
concentration, oxidizing power increases. See, if you take concentrated HNO3, okay,
Right.
what will it do? Concentrated HNO3 oxidizes the metals into higher oxidation state and itself gets reduced into NO2. Got it? For example,
Right.
if I take HNO3, it will convert itself into H2O, NO2, and nascent oxygen. But why nascent oxygen? See, the nascent oxygen is the part which will oxidize the metal or non-metal, whichever we are reacting that with. Okay. If it is metal present, metal will convert into its respective oxides like this. And if I write this in an oxide form, these oxides further react with HNO3 to convert into metal nitrates and H2O. Overall reaction is like this: metal plus HNO3 is giving metal nitrate plus H2O plus NO2.
Yes, sir.
Okay. So this happens with almost all the metals, beta. Okay.
Yes, sir.
Generic, I mean, any generic metal like mercury, tin, copper, lead, silver, right? Nickel,
Yes, sir.
cobalt, you take any of that, scandium, you take any of those metals, everything will convert into this. But
Yes, sir.
when it comes to metalloids, right? Metalloids like tin, arsenic, antimony. These three have metalloid properties.
Yes,
They will
sir.
convert into not nitrates but acids. So they'll convert into H2SNO3, H3ASO4, H3SbO4. Okay.
Right.
NO2 is the same, that is not changing. And thirdly,
Okay.
metals like beryllium, aluminum, chromium, iron, cobalt, nickel. Although I mentioned cobalt and
Right.
nickel, now see the problem here. All of them will do the same reaction, but because they first form an oxide, see the mechanism?
Uh-huh.
First, they are forming an oxide here, na?
Yeah,
Right?
yeah,
Once they become an oxide, they will lose out the access to the remaining metal. Okay? Because it forms a strong oxide layer on the surface. Got it?
yeah. Right.
So because they form strong layer on the surface, now they become passive. So the reaction becomes passive after that. Okay.
Yes, sir.
Lastly, if you notice gold, platinum, rhodium, and iridium, correct? They do not directly react with concentrated HNO3, but they can only dissolve in aqua regia. That is when you take 1:3 ratio of HNO3 and HCl.
Yes, sir.
Okay? Now this one you will practice again, beta. So start here. Reaction by reaction. First, this is the important reaction that you need to make a note, correct? And list out all the metals here, correct? Whatever all the metals which are doing this reaction. Next, metalloid reactions. Same reaction, but instead of nitrate salt, you will get this one. And lastly, which will give passive and which will not make any reaction. Correct? Chalo, do
Okay.
that. These are the reactions how the gold and platinum usually reacts with aqua regia. So gold, when you react with HNO3 and HCl, will convert into this form,
Yes.
a complex form, releasing NO gas. Same goes with platinum also. It will become H2. This is H2. H2PtCl6, known as platinic acid, plus NO gas. Okay. And you see,
Yes.
aqua regia appears to be yellow color due to the formation of NOCl. Correct. So here basically the NO plus which is present here will be again converted into NOCl. As you keep it for long standing, it will convert into NOCl form, which is yellow color form. Correct. Now what we discussed
Yes.
is with a concentrated acid, beta. Now check out with a dilute acid. See, now this time metals, when they react with dilute HNO3, they still get oxidized to form metal nitrates. But while doing it, there are two conditions that you need to check, right? First, if the metal is above the hydrogen in, electrochemical series, correct? Then you will get N2O.
Yes.
In that case, you will get this as N2O. That means anything which has a negative reduction potential. For example, if you have negative reduction potential, like zinc, nickel, clear,
Yes.
cobalt, right? These metals, they all have iron for that matter, everything. These have negative reduction potential. So when they react with the dilute nitric acid, they would release N2O gas. They will usually release N2O gas. But out of that, lead is the only exception. Although it has a negative reduction potential, it would give NO gas instead. Okay. While the metalloid nature metals like tin, arsenic, antimony, they
Yes.
will give you ammonium nitrate instead of giving N2O. Got
Okay.
it? So they'll give you ammonium nitrate. But if the metal is below ECS, which means they are all positive values, if they have reduction potential being positive value, in that case they will give you only NO gas. So copper, silver, mercury, these will have higher value. So they will give you NO gas here. Got it? So remember, lead
Yes.
is the only exception in this case, which is supposed to give N2O, but it will give you NO gas. Okay. Lastly, with very dilute HNO3. Very dilute HNO3, ammonium nitrate is formed for all the metals except for magnesium and manganese, which will instead give H2 gas. Like aluminum, we react, you will get ammonium nitrate. Iron, you react, ammonium nitrate. Zinc, you react, ammonium nitrate. Manganese, you react, you will get H2 gas instead of ammonium nitrate. Okay. Same case, magnesium, you react, you will get H2 gas instead of ammonium nitrate. So
Yes.
these two are the only exceptions what we will notice. Manganese and magnesium. And next, check it out. These are few organic reactions which we have come across before as well. Just a second. See, if you have toluene when you react with concentrated HNO3, you get this as 2,4,6 compound, which is TNT. Okay, trinitrotoluene. Okay, an explosive. Phenol, when you react with concentrated HNO3, majority of the form converts into quinone and minor product will be picric acid. While if you have a cyclic secondary alcohol on
Yes.
concentrated HNO3, they'll become ketone. And
Okay.
the ketones will further oxidize in concentrated HNO3 to give adipic acids.
Yes.
Cellulose, if you have on cellulose, the OH group will be converted into nitrate form, you know, at different position depending on how much concentrated you are adding. So that is called cellulose nitrate. So these are few forms or organic reaction forms which you will notice. Next, non-metals. See, non-metals, we usually react with concentrated HNO3 only. When you react with concentrated HNO3, carbon part will convert into carbon dioxide, phosphorus will convert into P4O10, or you can write it as H3PO4 after adding some water. S8 converts into H2SO4. Have you noticed everything is converting into their highest oxidation state
Yes. Mhm.
except for iodine? Iodine will convert into HiO3, not HiO4. It would convert up to iodic acid. HiO4 is an unstable form actually. That's why it would mostly exhibit into HiO3 formation. The product is same in all the cases. They release only NO2 gas.
Yes, sir.
Clear it up? Right. And now, other compounds, whether you take a dilute HNO3 or a concentrated HNO3, if I take S2 minus, it will convert always into sulfur. Okay. And now you might ask, sir,
Yes.
sulfur ko kya again, if at all I react with concentrated HNO3, something will happen? Yes, in fact, it will again convert into H2SO4. But as a first hand reaction, you will notice sulfur will form. I minus will convert into I2. Fe plus convert into Fe plus 3. Sn plus 4 convert into Sn plus 2 converts into plus 4. Oxalates convert into CO2. SO2 converts into SO4 2 minus. Okay. All of these are oxidation reactions of HNO3.
Yes, sir.
Yeah. Now, what are the oxides of nitrogen? See, nitrous oxide N2O, okay, which we call it as dinitrogen monoxide or simply nitrous oxide. So, ammonium nitrate, if you heat it, I told you that it is supposed to give N2, but there is an extra oxygen because of which it will be absorbed as N2O. Zinc, when you react with dilute HNO3, just now we have learned how to get N2O. When you take a dilute acid, anything which is above ECS, which has negative reduction potential, they'll give you N2O.
And to
And NH2OH in the presence of NaNO2, that will give you N2O and NaCl and H2O. Got it? N2O is a neutral, colorless, diamagnetic gas. Okay. J syllabus does not typically include the preparation reactions. This is just for the information sake, honestly. Okay. They have never asked the preparation reactions of oxides.
some
What they have asked is only the general properties, which is this one. That is, whether it is neutral, it is colorless, diamagnetic gas, and what is its structure looks like. This is what has been mostly asked. Okay. Next, nitric oxide. See, this also we learned that if I take copper, dilute HNO3, we'll get NO. You can take lead also. Lead is an exceptional metal which on reaction with
yeah,
dilute HNO3 will give NO. Oswald's reaction will also give an NO gas. Birkeland-Eyde reaction also have given NO gas, right? Next, nitric oxide that can be purified by passing the mixture of acid through aqueous FeSO4. Okay. And you see the brown ring form is an unstable form on heating, and shaking it again will give you NO gas release. This I told you earlier. Okay. How we get brown ring formation back to NO gas.
yes, sir.
Structurally, NO will have an odd electron present on it. So you can see this is an odd electron, because of which it shows paramagnetic character. It is still neutral and colorless. Okay.
Yes, sir.
The bond order is somewhere between two. I mean, it is at around 2.5, because you already have a double bond and that single electron keeps moving between nitrogen and oxygen, making it as half bond. Okay. At a low temperature, because of the unpaired electron present on nitrogen, it can slowly start making a dimer formation. Next one, nitrogen sesic oxide or nitrogen trioxide, N2O3. NO plus N2O4. These two can combine into a blue color solid, which is N2O3. Okay. So N2O3, we learned that as the anhydrate of HNO2. Correct. These are all repeat things only. You can just go through it once. Got it? See, N2O3 in solid state exhibits, once it is in a solid state, you will
Yes,
notice it
sir.
like an ionic bond between two ions, that is NO plus and
Yes, sir.
NO2 minus. Okay.
Yes,
In a
sir.
liquid state or a gaseous state, it will exhibit as like this N2. So it will have N double bond O, N double bond O, and one dative bond O here. Now, this is the most stable form, but there is the other form also which exists. That
Okay.
means the oxygen is at the bridge position between two nitrogens like this. Okay. So
Okay.
both
Yes, sir.
NN bond exist as well as NON bond exist. Okay.
Okay.
So there was
Yes,
a
sir.
JEE advanced question earlier where it has been said out of the following which has NN bond. Okay.
Okay.
So here in this case you'll have NN bond also and NON bond also. Okay.
Yes, sir.
Next, notice nitrogen dioxide. Any nitrate salt, any nitrate metal salts, any metal nitrate salts on heating, they will convert into oxides and NO2 gas will be evolved. You take any nitrate,
Yes, sir.
you can lead, copper, any of them, copper nitrate, zinc nitrate, lead nitrate, nickel nitrate, iron
Hmm.
nitrate, everything on heating, they'll convert into their respective oxides and releases NO2 gas on decomposition.
Yes, sir.
We also learned that how the reactions work with concentrated HNO3, that will also give you NO2. And we
Yes,
learned
sir.
from Birkeland-Eyde method or Oswald's method that NO plus O2 will also give you NO2.
NO2. Hmm.
In NO2 also there is an odd electron present on it. Okay, so it is a reddish
Yes, sir.
brown color. It is paramagnetic in nature. Okay,
Yes, sir.
and 2 moles of NO2 will convert into N2O4, and that is as well colorless, diamagnetic. It would be in liquid or solid state. Clear?
Yes, sir.
Now, liquid NO2 is used as a non-aqueous solvent and can be
What?
used to prepare anhydrous metal nitrates. Okay, what does that mean? N2O4, if you take it as a pure solution, I
हाँ
mean
जा
pure
रहा हूँ पानी
liquid,
पीने।
it will exhibit as NO plus and NO3 minus, not in aqueous form. Okay,
Yes, sir.
and since it exists as NO plus and NO3 minus, imagine I added zinc chloride to it. So that will convert into zinc nitrate, and this NO will take Cl, converts into NOCl. NOCl is that
Yes,
yellow
sir.
color liquid form. Okay.
Yes, sir.
Same way, if I take 2 moles of NO2, I will get NO2F. If I take 2 moles of NO2, I'll get NO2Cl. If I take XzF2 in their pure form, it will convert into NO2F and Xz. And NO
Yes,
and
sir.
Cl2, 2 moles of NOCl. NO and NOF also 2 moles of NOCl. NO and Xz also 2 moles of NOF and Xz. So these are same
Yes, sir.
reactions, if mind you. These are exactly same reactions, one with NO2, one with NO.
Okay.
And last oxide is nitrogen pentoxide. And this can be prepared by just dehydrating HNO3. So you take a
Okay.
strong dehydrating agent, P4O10, dehydrate HNO3, you can convert that into N2O5, and this converts into metaphosphoric acid. Okay,
Okay.
clear. N2O5 structure is like this, beta, where you have an oxygen bond at the center. And because these two will make a dipole moment here and these two will make a dipole moment here. So overall dipole
Mm-hmm.
moment will be 0, correct? So dipole
Yes,
moment is
sir.
0 in this case. It is diamagnetic. It is colorless. The minute you convert into solid state, it converts into NO2 plus and NO3 minus. Okay. Now remember,
Yes,
this
sir.
is the structures what you need to know. N2O3 in solid and liquid state will exist this way. N2O4 in
Mm-hmm.
solid and liquid state will exist this way. N2O5 in solid state exists this way. NO2 plus and NO3 minus. Correct?
Yes, sir.
Clear with the nitrogen part now?
Well, I